This is our group. This is RX and the replacement, or you can say substitution of this take place. This X or any group is being substituted with this nucleophile. Hello everyone, welcome to Toppers Academy, and today we are going to discuss about a nucleophilic substitution reaction. It is a very important topic regarding class 11th and class 12th chemistry. So when you start with your chemistry, you have to deal with the various type of reaction such as addition reaction, substitution reaction, elimination reaction, and the rearrangement reaction. So basically from this only we have taken for today the substitution reaction. The substitution reaction also constitutes of various subparts such as nucleophilic substitution, electrophilic substitution, and free radical substitution. Today we are going to discuss with the nucleophilic substitution. What happens over here, as the name implies, that nucleophilic, the two part of this name, nucleophilic and the substitution. And substitution, we know that something is going to be replaced, or you can say displacement. If there is a group like this RX and another moiety such as NU, nucleophile, so what is going to happen over here? Here is the replacement is going to take place from plus this X negative. What is happening over here? We can see that this is our group. This is RX and the replacement, or you can say substitution of this take place. This X or any group is being substituted with this nucleophile. This group is nucleophile. When we talk about the nucleophilic substitution, then this type of reaction, nucleophile with the substrate. And when we discuss about the electrophilic substitution reaction, then this is replaced with the electrophile. I hope that you know about the nucleophile. Those who doesn't know what is the nucleophile, for them nucleophile is nothing but a group which loves the nucleus, because over here phile means loving and nucleo means nucleus. So nucleophile is a moiety which loves the nucleus, which means an axis of electron is there. So such type of group is going to initiate this substitution reaction. So basically these substitution nucleophilic reactions are of three types: SN1, SN2 and SNI. There are very many other reactions such as SN, NGP and much more. But for our syllabus point of view, we are going to deal with this SN1, SN2 and SNI. This is the substitution nucleophilic or nucleophilic substitution unimolecular, SN1, as the name implies over here. And when we talk about this SN2, it is nucleophilic substitution bimolecular, and this SNI, nucleophilic substitution internal or intramolecular, which means that some internal rearrangement or reaction is going to take place. So firstly we will discuss about the SN1 reaction. So what is going to happen in this reaction? A nucleophile is going to attack. A nucleophile is going to attack, and let's say it is our substrate, and this is a nucleophile. This is a nucleophile and this is a substrate, and this is our product. This is our product. Yeah, sorry. The group which leaves is known as the leaving group. Plus, you can see over here X negative, which is our leaving group. This is the leaving group which is going to leave from the reaction, and this is our substrate Rx. This is termed as substrate, and this is our reagent which is initiating the reaction. It is the reagent which is initiating the reaction. So what is the special about this SN1 reaction? In SN1 reaction, the rate of reaction is dependent only on one substrate. Over here, two things are taking place in the reaction: substrate and reagent. Two moieties are there which are taking place in this reaction, but rate of reaction will be dependent only on the one moiety. How this reaction is taking place, how this is dependent only on one reactant, that will be shown by the reaction mechanism, because it is a two-step reaction. It is a two-step reaction. In the two-step, first step I will show you. In the first step, what is going to happen? In the first step of this SN1 reaction, let's say this is our substrate. If this is our substrate, and this is our first step, and it is the rate determining step. This is the rate determining step, or you can say a slow step, because in this step what happens? This bond breaking takes place. This bond breaking takes place, and it becomes like this. If we arrange the group like this, let's say it is R1, R2 and R3. This is our R1, R2 and R3. If this is the case, we can see over here this group leaves. This X is leaving over here in the first step, where R1 can be equal to R2, can be equal to R3, and they are alkyl group. Most of the time they are alkyl group. So what happens over here? This is a tetrahedral structure. This is a tetrahedral structure in which these two bonds are above the plane. This bond is above the plane, and this bond is below the plane. And these red color bonds are on the plane. These red color bonds are on the plane like this. This is these bonds are on the plane, and this solid line is above the plane, which means away from towards the observer. And these dotted lines, they are away from the observer. They are behind this board, and this bond is away, this towards me, which means toward the observer. This bond is away from the observer. So this type of bond is there in this tetrahedral structure. But what happens after this? These all three bonds are on the plane only. All three bonds are on the plane only: R1, R2 and R3. And this is a carbocation. This is a carbocation as visible. So we can see that only one substrate is taking part in the reaction. Only this is taking part in the reaction, and no nucleophile is present. That's why this is only taking place. This is only responsible for the rate of reaction. No nucleophile. In the second step, what happens? This planar, it is a planar structure. It is a planar structure, and what happens over here? At this planar structure, the nucleophile attacks. The nucleophile attacks at this planar structure. And we can see over here that there are two possibilities because it is a planar like this. So the nucleophile came from the upside, and there is another possibility that nucleophile can come from the downside. So two possibilities are there. If we consider this molecule like this, so one possibility is nucleophile can come from this side and another from the back side. If you arrange it like this, the one possibility is like this and another is like this. But when we are having this tetrahedral structure, it is like this. So one bond is like this and another is this, and this is in the plane. So like this. So this is a planar molecule, and there are in planar there are two possibilities, either from upside and from the below side. So if this nucleophile, if this nucleophile attacks from the upside, and it can also attack from the downside. So we can have two different possibilities. This is the nucleophile when it attacks from the down. And when it attacks from the upside, it is like this. These bonds are above the plane and below the plane. So there are two possibilities. If this R1, R2 and R3 are different groups, then this molecule is chiral. This molecule is chiral, and we will get a racemic mixture. We are going to get a racemic mixture. And those who have studied the stereochemistry, they know what is a racemic mixture. The R and S, the mixture of R and S, stereoisomers. So this was the case. If we see the rate of reaction, it is only dependent on Rx, not the nucleophile. It is the directly proportional sign over here. And if we want to remove this rate of reaction will be equal to a constant and Rx. We can very easily see that this is dependent only on this substrate. No nucleophile is present in the rate determining step and rate of reaction. So the reaction will be wholly dependent on the first step. And in the first step, we can see a carbocation formation is taking place. In the first step, the carbocation formation takes place. So we can easily see that this SN1 reaction will be dependent on the carbocation stability. Carbocation stability. If we want to draw the energy profile diagram, if we want to draw the energy diagram of this rate is reaction, SN1 reaction, this is the progress of reaction. On this axis we can see that the progress of reaction, and at this axis, y axis, we can see the potential energy. If we start the reaction at this stage, which means the Rx, which means the reactant. If this is the reactant side, the reaction will proceed like this. like this. So here we can see, because it was a two-step reaction. It was a two-step reaction. Let's say it is the amount of energy which is being supplied. That is termed as EA. That will be termed as EA. Energy of activation. This is the transition state 1 or the transition state of the first step. Here it is the carbocation. Here this is the carbocation or intermediate which is being formed in the first step. And this after it is the second step transition state, TS2, transition state second. And this is our product. This is our product, R nucleophile. This is our product, R nucleophile. Over here we can also see one thing, that if we see over here, there is a change in energy. We can see a change in energy, and the product energy minus the reactant energy. That's why delta H will be negative. Delta H over here will be negative because it is a lower energy, and we want subtract the product energy, reactant energy from the product energy. We will get a negative value. So this is the energy profile diagram. And what are the factors on which this? What are the various factors on which this reaction depended? First thing is the substrate. We have already seen that. And the second thing is your solvent. Second thing is solvent. Third thing is leaving group. Third thing is leaving group. Fourth is our nucleophile. And fifth is our steric crowding. So these are various factors on which this reaction depends, and same factor we will see in the SN2 reaction also. As we have seen that SN1 reaction, it is a one-step reaction. As we have seen, SN1 is a one-step reaction, means unimolecular. SN2 we will see in the next lecture that it is a bimolecular reaction or one-step reaction. This is a two-step reaction and it is a one-step reaction. It is dependent on we have seen in the previous slide that it is dependent only on one reagent, unimolecular. So in this rate of reaction will be dependent on the both two substrates, which means nucleophile and the substrate Rx. So that's why it is bimolecular. And here we have seen that it is a carbocation is formed. Formation of carbocation have been taken place over here, which means intermediate. But when we will discuss the SN2, we will see that no carbocation, only one transition state. In this we have seen two transition states. So these are the various things which are quite interesting to know that how this reaction is being proceeding. So for today we will discuss about a substrate, that on which substrate this rate of reaction of this SN1 depends. As we have seen that carbocation is formed. Carbocation is formed in the first step, or we can say the rate determining step. So that's why what will happen, this will depend, as we know that 3 degree carbocation is more stable than 2 degree carbocation, and which is more stable than 1 degree carbocation. So this is the stability of carbocation. So that will be the rate of reaction, which means SN1 reaction will follow the same procedure, which means 3 degree, 2 degree and 1 degree. In the same manner, SN1 will follow 3 degree more than 2 degree and then 1 degree. But this order will be reversed when we will study the SN2 reaction. In SN2 reaction, 1 degree is more preferable than 2 degree than 3 degree. In this, due to this carbocation, and this is the effect of the substrate. When we see the solvent effect, it is dependent on a polar protic solvent. Polar protic solvents are responsible over here. Polar protic solvents are those solvents which are polar, which means a different pole, positive and negative. And protic means a hydrogen is attached or H is attached on a protic group, which means a more electronegative atom, like this, a group like this, HO2, OH2, ROH, CH3, C double bond O, OH. These groups are polar groups. Because we have seen that RS, bond breaking, RX bond breaking takes place, and here it is a plus and it is a partial negative. That's why we need a partial polar character to break this bond. And after this breaking, this X needs to be covered up. So this hydrogen will cover up. This hydrogen will cover up. Due to this, hydrogen will cover up this like this. Let's say I have written this R for solvent. So this R will cover up because it is having a positive charge. So it will cover up this leaving group. So it will be interesting to see that this cover up this leaving group and the reaction will proceed. So that's why solvent for this is polar protic. But when we discuss about the SN2, we will see that it needs a polar aprotic solvent. Polar aprotic solvent. When we see about the nucleophile, in SN1, no effect of nucleophile, because reaction is dependent only on substrate, so it doesn't affect the rate of reaction. And when we see the leaving group, which means a good leaving group, because in this we have seen the RX, this need to be leave. This need to be leaves. So this should be a good leaving group. If it is leaving, then only another group is going to come. So that's why a good leaving group. We need a good leaving group. So there are various other characters. We have discussed about this in short. About substrate, we have seen that 3 degree more stable than 2 degree. For solvent, we have seen that polar protic solvent. For leaving group, a good leaving group. And for nucleophile, it doesn't affect the rate of reaction of this SN1 reaction. If we see the steric crowding effect, I will show you like this. In this, it is a tetrahedral structure. And after the transition state, it exists in this state. So here the angle is 109 degree. If these groups are bulky, they will tend to remain in this position. That is more favorable for them because the angle is 120 degree. They are far apart. So that's why crowding groups prefer the SN1 reaction. And when we see the SN2 reaction, this will be reversed. So I have shown you over here why this crowding group prefer this SN1 reaction, because in this the angle is changing from 109 to 120 degree, which is quite the more space is there. So these bulky group prefer the SN1 reaction. So that's all for today, and in the next chapter we will we will discuss about the SN2 reaction and SNI. Thanks.